This is lecture 2.2. We are going to continue our discussion of variables, assignment statements, and operators. So operator precedence or operator order of evaluation follows the standard order of operations that you probably learned in grade school. So you probably learned some sort of mnemonic device. I remember learning, please excuse my dear Aunt Sally. So parentheses, exponent, multiply, divide, add, subtract, with parentheses being the highest priority in the list. So just as we use parentheses in mathematics to designate and establish a priority, we can use parentheses in expressions when programming to establish priority as well. So by using parentheses in the two example statements, we're able to choose whether or not the multiplication occurs first or the addition occurs first. Obviously, if you remove the parentheses altogether, multiplication is a higher priority than addition. So if we did not have the parentheses at all, the multiplication would occur before the addition. But by using parentheses, we're able to control the order of precedence. Operators are often split based on how many operands they require. A unary operator, in this case unary plus and unary minus, are going to take a single operand, and the plus will make the number positive while the minus will make the number negative. A binary plus is going to require two operands and is going to perform addition, while a binary minus is going to perform subtraction on two operands. An example of this would be in this situation we have a minus sign followed by a 5. So the minus sign is an operator. It's a unary minus. Then we have the literal 5 followed by the operator plus. It's a binary operator. And the integer literal 7. So when this evaluates, the negative affects the literal 5 and makes it into a negative 5. Then the plus is going to take the 7 and the negative 5 operands and perform addition, with the result being positive 2. In the bottom example, we have parentheses, which changes the precedence and performs the addition using the binary plus operator and results in a 12, which then we have a unary minus acting on the result of the addition, which is 12, and that results in a negative 12. So both examples, the minus is a unary operator, which negates a value, and the plus is a binary operator. It's common to have multiple binary operators of equal precedence in a single expression. So, for instance, here we have 1 plus 2 minus 3 plus 4. These binary plus and minus operators have the same precedence. In this situation, we evaluate left to right. So we would add 1 and 2, get the result as 3. 3 minus 3, 0, 0 plus 4, 4. And the effect is shown here using parentheses to show which occurs first, and it's just grouping from left to right. When unary operators have equal precedence, however, they are evaluated right to left. But this is not very common, so it doesn't come up very much. It's often possible to structure a mathematical or arithmetic statement in such a way that it evaluates correctly and gives you the right answer without using very many pairs of parentheses. However, parentheses tend to make something more readable, and our goal is always to write code that is readable, because readable code is typically maintainable code or more maintainable code. So therefore, it's often better to use parentheses to show what you intend to occur. So, for instance, using the parentheses here is not necessary because the multiplication will occur before addition because multiplication is a higher precedence. However, by putting them in parentheses, it makes it obvious what we intend to occur. Also, using spaces makes it a little bit easier to read. So by spacing out 1 plus the quantity 2 times 3, we're able to more easily read the arithmetic expression. However, spacing does not alter precedence. So in the bottom statement, it could seem that by spacing it in this way, we're designating some sort of change in precedence. It may look that way, and to us it might read that way, but to the computer, to Java compiler, it will evaluate precisely based on the precedence of the operators. 3 times 4 is going to result in 12. Then we have 1 plus 12 minus 2, and plus and minus are of equal precedence, so it'll be the 1 plus 12, which is 13, then 13 minus 2 is 11. So far, we've talked explicitly about integers, but to be able to make a literal a real value, and in this class we'll refer to doubles as either doubles or reals. Floats would be a single point precision floating point value, with double being a double precision floating point value. To be able to make a literal into a double, we add a .0 or simply a period following the number. So for instance, 2 is an integer. 2.0 is a real. 2 point is also a real designation. Other examples of this: 6.02, that would be a real. Negative 42.0, real. You can also use scientific notation. So you could do 2.143 E17, so that would be 2.143 times 10 raised to the 17th. So the operators we have covered so far are all compatible with real value literals and real value variables. The division operator produces a double answer. So just as when we were dealing with integer values and doing division, the result was a integer. In this case, if we're using reals or doubles, then the result of division operator is going to be a double. So whereas previously 15 divided by 2 would have resulted in 7, now using reals we get the real answer we would expect, which is 15.0 divided by 2.0 equals 7.5. But often it's not realistic to have expressions which are entirely of a single data type. So what happens when we mix integers and reals, ints and doubles? Well, a situation that would be similar to this would be if we wanted to know how much tax we were going to have to pay on a $5 Subway sandwich given an 8.75% tax rate. So our 5 would be an integer, while 8.75 would be a real or a double. Any operation involving both integers and doubles will result in a double value. So, for instance, 4.2 is a real, and when we apply the operator, the multiplication operator to 4.2 and the integer 3, the result is a real 12.6. So it's important to understand how this occurs, because the conversion doesn't happen to the entire expression at the same time. The conversion happens on a per operator basis. So it affects only the operands involved in the current expression evaluation. So to explain what we're saying explicitly, in this statement we have 7 divided by 3 times 1.2 plus 3 divided by 2. Okay, in precedence, division and addition are equal. Anytime you have equal precedence, you evaluate left to right. So we begin with 7 divided by 3. 7 and 3 are both integer literals, so the result is a 2. The result has a remainder of 1, but because it's an integer division, the remainder gets chopped off, and we're left with the integer result of 2. So we have evaluated the first expression. The resulting expression is 2 times 1.2 plus 3 divided by 2. The next highest precedence operator is multiplication. Multiplication and division have the same precedence. However, we evaluate left to right in situations of equal precedence, so the multiplication goes first. We have an integer and a real. So an integer multiplied by a real results in a real. So now we have 2.4. So the new expression is 2.4 plus 3 divided by 2. All right. The division has the highest precedence in the operators which are left to be evaluated. So we do 3 divided by 2, but notice it's an integer 3 and an integer 2. Even though we have a real in the expression which has been evaluated, it does not affect the current evaluation. It's only the operands in the current operation affect the data type. So 3 divided by 2, both being integers, results in 1. Now we're left with 2.4 plus 1, the result being 3.4. If we had expected this expression to be evaluated entirely as a double, so 7.0 divided by 3.0 times 1.2 plus 3.0 divided by 2.0, then we would have gotten the wrong result, because we did not expect and understand that the division of 7 divided by 3 and 3 divided by 2 would occur as integer division, and therefore the remainders would be chopped off. So 3 divided by 2 equals 1, not 1.5. So if we wanted the results of 7 divided by 3 and 3 divided by 2 to be reals, we could have made either of the operands into reals, and the result would have also been a real. As an example, 3 divided by 2.0, so the integer 3 divided by the real 2.0 is 1.5. Integer divided by real equals real. Integer divided by integer equals integer. Integer times integer also equals real. So there are multiple ways to force a conversion to real should you want to make that occur. To verify that you understand operator precedence and how they will evaluate, take a moment and pause the video and attempt to evaluate this expression and check it against the answer that we give. So we'll begin by adding parentheses to show what the evaluation will look like. So first of all, the current state of this expression, the highest precedence operator is going to be the multiplication on the far left, because we have 2 multiplications and a division, all of which are higher precedence than the addition, and multiplication and division are equal precedence. So in the situation of equal precedence operators, we evaluate left to right. So the very first operator to be evaluated will be 2.0 times 2.4. Once this operation has completed, the next highest priority operator will be the next multiplication, moving to the right. Following this, the next highest priority operator will be the result of 2.25 times 4.0 divided by 2.0. And finally, we will get to the addition. So let's look at how this plays out. So our first operation results in 4.8. Following this, we apply the multiplication operator to 2.25 and 4.0, resulting in 9. Then we apply the division operator. 9.0 divided by 2.0 is 4.5. And notice these are all reals, so there's no integer results to have to deal with. And then we do 4.8 plus 4.5, resulting in 9.3. Something that can occur when doing arithmetic operations is overflow. If, for instance, you multiply two very large numbers together, then you may wind up with a result which is too large to fit in the data type to which it is being assigned. For instance, if you were to add 68 and 68 and attempt to store this in a byte, well, the result of 68 plus 68 is 136. 136 is larger than the maximum size storable in a byte, and therefore an overflow will occur. Another example of this would be attempting to store the value 3 billion into an integer. So an integer can hold 214,748,3647. 3 billion is in excess of that number. Therefore, 3 billion would cause an overflow if you attempted to store the number 3 billion into a variable which was an integer type. As we mentioned previously, the maximum storable value is directly related to the size of memory occupied. So in the case of an integer, it's simply that when the number 3 billion is represented as an integer, it takes up more room than the allocated 4 bytes for an integer type variable. So if you were needing to store the number 3 billion in a variable as an integer, you would need to store it in a long. So to review our operator precedence, the highest operator precedence is going to be plus, minus, plus, plus, and minus, minus, and exclamation mark. If you don't know what some of these mean, don't worry. Following unary operators, the next highest precedence is binary arithmetic operators, specifically multiplication, division, and modulo. So these all have equal precedence. Following multiplication, division, and modulo, the next lowest precedence binary arithmetic operators would be plus and minus. And when operators have equivalent precedence in a single expression, they evaluate left to right. In the last slide, we saw operators which were plus plus and minus minus. These are unary operators that affect the value of a variable. The way that they affect the value, plus plus is an increment operation, and minus minus is a decrement operation. Now there's two versions of this. If plus plus occurs before, as in this first example, then this is considered a pre-increment. If plus plus occurs after the m, this is considered a post-increment. The way that pre and post increment affect the evaluation is as follows. In this first example, we have variable declaration of m as an integer, and then we assign m the value 4. And we end with a semicolon. Then we declare the variable result as an integer, and we assign it the value 3 times plus plus m. So plus plus m is a unary operator and a variable m. The unary operator plus plus is going to increment m first and then return the value of m. So plus plus occurs before the value of m is accessed to give the value of m to the rest of the expression. So plus plus increments m to 5, and then 5 is returned to the expression, and then we multiply 3 times 5 to result 15. In a post-increment situation, which we show below, we have m equals 4 and result equals 3 times m plus plus. M plus plus is going to return the value of m first and then increment. So the value of m is returned, and we multiply 3 times 4, and that's stored into result. So result takes on the value 12. After the value 4 is returned from m, it then increments m to 5. So in both situations, the ending value of m is 5. However, which occurs first is determined by whether the pre-increment or post-increment order is used. Pre-increment is going to increment the variable and then return the value. Post-increment is going to return the value and then increment the variable. It's very important. It's easy to get that mixed up. A confusing situation can occur if you attempt to do something like is shown in the bottom left-hand corner. If you have a variable m, which has the value 4, and then you attempt to assign m the value m plus plus, then the way that this will execute gets a little bit complicated, and it's important to understand exactly what has precedence and what will execute in what order. So first, the unary operator has precedence over the assignment operator. So plus plus will return, so it's a post increment, so it will return the value of m and then increment m. So m is now 5. However, after incrementing m, the value which was returned, 4, is assigned to the variable m, which makes the value again 4. So in this situation, m will wind up being 4. The plus operator can be used on data types other than integers and reals. It can also be used on strings to perform a concatenation. So if you wanted to have the resultant string hi there, you could break that into 2 string literals, one being hi, one being there, and combine them using the plus operator. Now, all the precedence rules that we have discussed thus far and the rules of conversion apply. So let's look through this list. First, we have hi and there, as we discussed, that gets concatenated to hi there. We have hello plus the integer 42. So just as we had a data type conversion when we had an operator which did an operation on a double and an integer, and then the value which was the evaluated value then was a double. Similarly, if we have a string and an integer, the resultant value is going to be a string. So hello plus 42 is going to result in the string hello 42. In the situation below, we have ABC plus 1 plus 2. So we have 2 pluses, in which case both have equal precedence. We evaluate left to right. So we have ABC plus 1. This will evaluate to the string ABC1. Then we have the string ABC1 plus integer 2. The resultant is the string ABC12. But what if we reverse the order? Now we have 1 plus 2 plus ABC. Again, we evaluate left to right because the pluses have equal precedence. So we have the integer 1 plus the integer 2. The result is going to be an integer 3 because both of the operands have data type integer. So we have 3 as the result of this operation. Then we have 3 plus ABC. So our operands have data types integer and string. So the result must be a string. So 3 plus ABC is going to result in 3ABC. So the rules stay the same. An operator is going to only consider its operands when determining the resultant data type. In the next example, we have ABC, which is a string, plus 9 times 3. Multiplication is a higher precedence than addition, so therefore multiplication is going to evaluate first. 9 times 3 is 27. Then we have ABC plus 27. So we have a string and an integer, so the resultant will be a string. The result is ABC 27 as a string. We have the string 1, and we are adding it with the integer 1. The result will be a string. So we have 1, 1 as the result of that expression. And finally, we have 4 minus 1 plus ABC. So we have negative or we have a minus and a plus. Minus and plus have the same precedence, so therefore we evaluate left to right. 4 minus 1 is 3 because they are both integers, so the result will be an integer as well. 3 plus ABC. ABC is a string, therefore the result of integer plus string will be string. 3 plus ABC is going to result in 3ABC. Using plus to concatenate values and strings is very helpful when you want to display a numeric value and some string or explanation with a numeric value. As an example of this, system.out.println, we can do a println statement that shows the explanation grade with a colon and space, followed by the expression which determines a student's grade. And then the output would look something like this. Grade colon space 83.5. So using plus to concatenate a string and an integer value or a real value is very helpful when needing to display something to the screen using print or println. In the following class called receipt, our main method is calculating the total cost of a meal. So built into this cost, we have the subtotal of the meal, the tax, and the tip. And then we are summing those to get the resultant total. However, this code, as it's written currently, leaves a lot to be desired. The first thing to notice is the redundancy. 38 plus 40 plus 30 occurs 6 times in this method to calculate the same value. That's a problem for multiple reasons. It's redundant and inefficient, but also from a programmer standpoint, if for some reason I needed to change the 38, I have to change it in 6 locations. I'm probably going to forget at least one of those, and now I've introduced an error into the program because it will no longer correctly calculate the total cost of eating at this restaurant. So this redundancy is a problem. And then further, the code isn't very readable because with all the print line statements, it's a bit ugly and messy to read. We will fix this code and show what a better version of it would look like after we revisit variables and values. Data is stored in variables. Typically this data is numbers and letters, and the specific data that is stored in a variable is the variable's value. So a simple analogy to understand exactly what we're saying here is if you had an MS Word file on your computer, this file has some name, and inside it there is some data. So the name of the file would be the name of the variable, and the contents of the file would be the value of the variable. But the way this works functionally, variables are actually memory locations in Java. So a specific variable actually exists in a memory location in your computer, and that's managed by the Java compiler and the runtime, JVM. And fundamentally, the reason variables are called variables is because their values vary. So the value which is stored in a variable can be changed. So as an example, if in a program you have a variable named studName, at one point it might have the value John. But later on, you may progress and be evaluating a different student named Mary, and therefore studName will be assigned the new value Mary. And going back to our MS Word file analogy, we can have one file called My Paper, and you can write a paper in that file, but then you can go back later and decide you don't like it, and you can delete part of it and change the paper. The file hasn't changed, the variable hasn't changed, but the content of the variable has changed. Similarly, we can have this variable called studName, and we can change the content of the variable. So every variable has a name and a type. The name is an identifier, and it must follow the rules and the style which we have discussed previously. The variable type indicates what kind of data can be stored in the variable. So integer, double, char, those would be types, and those are the types of data which may be stored in that variable. To be able to use a variable, you have to declare it, and it must be declared before you use it. So to declare a variable in Java, you have to provide its type and name. An example of this declaration would be int number of baskets. So that's a declaration, and you end the statement with a semicolon, as always. So for good style, when choosing an identifier for a variable, you choose a name that is helpful. Count or average would be much better than something not very descriptive like C or S or my stuff. Using words that have enough meaning to be read and understood increases the readability of your program. So the general syntax for any variable declaration is the type of the variable, followed by the variable name, and then if you so choose, you can declare multiple variables using a comma followed by another variable name, which will be of the same type as the previous name. And you can continue to add additional variables to this list using commas to separate, and then terminate using a semicolon. Examples of this would be int count, comma, number of checks, semicolon. So we have declared two variables, one named count with the type integer, and one named number of checks with the type integer. Another way of accomplishing the same declaration would be to have int count, semicolon. So we have declared the variable count, and then we have int number of checks, semicolon. So we've declared the variable number of checks with type integer. One of the benefits of doing individual variable declarations on each line, so one variable declaration per line instead of doing multiple declarations in a single line, is that you're able to comment each variable independently. That's an added feature. There is a way to be able to make use of the multi-variable declaration and comment individual lines. So it's also acceptable to declare variables in the following way: the type followed by the name, comma, and then you can actually do an enter or carriage return, and then place the next variable name on the following line. Notice you can't put a semicolon in here, otherwise that would terminate the statement. So this statement remains unterminated. It follows the next line. You're able to place the next variable name, place a semicolon. In this way, we're able to place a comment on both lines to allow for documenting each variable independently. So we've discussed how to declare a variable. Next would be to discuss when, where, and with what style you should declare variables. So as far as when, the only rule you have to really follow is that a variable must be declared before you attempt to use it in the program. That makes sense, right? You can't use something that doesn't exist. So to use a variable, you must first declare the variable. And there's typically two places that variables are declared. One is at the very beginning of a method. So at the top of the main would be an example of the beginning of a method. And the other would be the line where it is first used. So you can simultaneously declare a variable and use it. So as far as the style, so notice down here in this example, you should always include a description of the purpose of the variable in the program. So we've got a main method, public static void main, and then at the top of our main method, which is the method in which we are going to use this variable, we have declared the variable named total of type integer, and we end the declaration with a semicolon, and we have given a comment to say that it's going to hold the total of test scores. Once you have declared a variable, you'll typically want to assign it values. So in this case we have a variable called answer, and we're assigning the variable answer the value 42. So when we assign a value, we're using a specific type of statement called an assignment statement. An assignment statement is an expression which is used to assign a value to a variable. So the assignment operator in Java is the equal sign. So the equal sign is the operator which we use to assign a value to a variable. And we should not understand the equal sign to mean that two things are equivalent, but rather we should understand that anytime you see the equal sign in a Java program, what is happening is you're assigning a value to a variable. As in the example, we have the variable answer and we assign it the value 42. Another example of this would be we assign the variable count. So we have the variable count and we assign it the value count plus 1. So the value that we assign to a variable can itself be an expression. So we have a variable which we assign the value of this expression. So this would be another way to increment count. We talked about the plus plus operator, the unary operator, which would increment a variable. You can also increment a variable directly simply by doing count equals count plus 1. And this will increment count by 1. The syntax of the assignment statement is always variable on the left with the expression on the right. So we have a variable which we wish to assign a value. We have the assignment operator, and we have the expression which, when evaluated, will yield the value we wish to assign to the variable. So the variable goes on the left, the assignment operator in the middle, and the expression on the right. And as we've said previously, an expression can be a literal, a variable, a constant, or some combination of operators, variables, literals, and constants. So we're using the term expression here in its technical sense that we introduced previously. In the examples below, we see the variable amount being assigned the value 3.99. So in this situation, we have the variable being assigned an expression, and in this case, the expression is a double literal. So it is a double value literal. In the next example, we have a variable called first initial, and it is being assigned the literal character W, uppercase W. And then in the bottom example, we have average, a variable named average, being assigned the expression quantity test1 plus test2 divided by 2.0. So in this case, our expression will calculate the average of two test scores and then store the result in the variable average. So making it a little more clear exactly how an assignment evaluation occurs, in the example we have here, we have politicians who lie as a variable is assigned the value of resulting from the expression politicians who lie plus 1. So the expression on the right hand side of the assignment operator is evaluated first. The result of the right hand side expression is then assigned to the variable politicians who lie. The effect in this situation is that we are incrementing by 1 the value of politicians who lie. So this would be a way to implement, say, a counter. If you wanted to make something increment by 1 or count up by 1, this would be a way of going about it. Also, as I mentioned a moment ago, you could use the unary plus plus operator as well. So we've said previously that storing something in a variable requires that the variable exists. So you have to declare the variable before you want to store something in it. As a further rule, before you're allowed to use a variable in an expression, you must assign the variable a value. So as an example, if we want to have the statement print line and give the print line method the arguments x is space as a string and then plus x, then we first must have a value stored in x. So we declare the variable x, we assign the variable x the value 3, and then our print line statement will evaluate as follows. We'll have a string x is space plus x. So anytime you have a plus operator with the operands being a string and an integer, the result will be a string. So the integer value will be concatenated into the string, and so the result is going to be a print line statement that shows to the screen x is 3, as shown over here in the comment. And then the following line will print 5 times x minus 1. So the operator precedence here, the multiplication is going to go first. We're going to do 5 times 3 is 15, then minus 1 is going to be 14. That will be shown to the screen. So you can only hold a single value at a time in a variable. If you change it or assign a new value, the old value is completely erased. It's permanently erased. An example, we have a variable x, so we have declared it as an integer, and we've set it equal to 3. So here we've done the declaration and the assignment all in the same statement. And then we are going to do a print line statement to display the value of x to the screen, and we display the value 3. Then we assign x the expression, or the value resulting from the expression, 4 plus 7. So the expression on the right of the equal sign, on the right of the assignment operator, always evaluates first. So 4 plus 7 evaluates first, and we have the result 11. The result of the expression is then assigned to x. So now x has the value 11. So when we do the print line statement in the following line, we print to the screen the number 11. There's a common error that you will most likely do at some point in your time as a programmer, which is attempting to make use of a variable in an expression before you have assigned the variable a value. So what we would say about this variable is that it is uninitialized. So we have a variable which is declared. So we have x is an integer, and then we attempt to use it in this assignment statement, and we attempt to pass x as the argument. Well, the compiler will generate an error and say that x has no value. There's an error related to this, which is a duplicate declaration. So if you have a variable already declared called x, and you have some code, and then somewhere later on in the code you attempt to declare a variable named x again, then you're going to encounter the error x already exists. In this case, the problem is you're attempting to declare a variable of the same name within the same scope. So in the same set of curly braces that encloses a section of code, you have attempted to declare another variable of the same name. To recap, before a variable can be assigned a value, you must declare the variable. Before the variable can be used in an expression, you must assign it a value. And if a variable already exists in the scope, you cannot declare it again. There are specialized assignment operators that are used to perform common operations and assign the value resulting from the operation in a more compact form. In the examples we see here, we're taking the variable amount and we're assigning the variable the result of the expression amount plus 5. So we're incrementing amount by 5 is what we are trying to do. A way to do this in Java with a more compact representation would be amount plus equals 5. So understand that when you see amount plus equals 5, this is precisely the same as amount equals amount plus 5. You are incrementing amount by 5 and storing the result of that expression into amount. But you can do this with most of the arithmetic operators. So in the bottom table, you'll see several examples. You can do variable plus equals some expression to be able to add the result of the expression to the current value stored in the variable, and then store the results of the overall operation to the variable. So that would be equivalent to the right-hand side. Variable equals variable plus some expression. You can do the same thing with minus. So variable minus equals expression is the same as variable equals variable minus expression. And you can do the same thing with multiplication, division, and modulo operators. Two common operators that we have discussed already are the increment and decrement operators. And you can have those in both formats of post-increment, pre-increment, post-decrement, pre-decrement. Though you may personally choose not to use any of the shorthand operators, you may not choose to use the post or pre-increment operator, you may not choose to use the shorthand version of assignment and expression evaluation shown on the previous slide, it's important that you're able to recognize and understand what they do and how they evaluate. Because even though you may not use them, someone will use them and make use of them, and they are valid syntax in the Java language. So it's important that you're able to read and understand how these operators work, even if you choose not to make use of them. In this slide, we're showing that there are several ways to increment or decrement a variable that we have presented, but it's important to understand that even though the result on count is precisely equal in all of these situations, it should not be understood that post-increment and pre-increment are precisely the same. Remember, post-increment will return the value to the rest of the expression and then increment count, whereas pre-increment will increment count and then return the value to the rest of the expression. So although these are equivalent in their effect on count, they post and pre-increment are different, and they've been covered in a previous slide. So both of these are increment operators. We can also increment count if we wanted to by doing a simple assignment operation and using the value of count and adding 1 to it and assigning that to the variable count. We can shorthand that by saying count plus equals 1, and that's exactly equivalent to the statement above it. The same can be said for the statements in the bottom of the slide. We have a post decrement, which is going to return the value, then decrement the value of count. Then we have a pre-decrement, which is going to decrement the value of count, then return the value to the rest of the expression. And we have a simple assignment, which is going to take the value of count, subtract 1, and then assign that resultant value to the variable count. And then we have the shorthand version of that, which is count minus equals 1. Make sure that you understand how all of these statements work and how they all achieve the same end result effect on the variable count. We've said this previously and touched on it a couple of times, but it's very important to drive home. If the only thing in the expression is an increment or decrement of the variable, then pre or post are precisely equivalent, because there's no greater expression to which the value is being passed. In that situation, probably best to use a pre-increment because it is a bit more efficient due to the behind-the-scenes implementation in Java. However, if the increment and decrement are not the only operations in the statement, then you have to be very intentional about the choice of pre-increment or post-increment, because as we've discussed, x equals x plus plus is not the same as x equals plus plus x. Remember, a post-increment will return the value of the variable and then increment the variable, whereas pre-increment will increment the value of the variable and then return the value. We've mentioned this, but just to make sure that it's very clear, you can both declare a variable and assign a value in the same statement. So to declare a double called dog GPA and assign the value 3.95, we can use the statement double dog GPA, assignment operator, then the double literal 3.95 terminated with a semicolon. This statement is going to both declare dog GPA as a double variable and assign it the literal value 3.95. Similarly, we can do the same thing with an integer variable x, and so we have declared an integer variable x and assigned it the value which will result from the expression 11 mod 3 plus 12. When using an assignment operator, we always evaluate the right-hand expression first. So we have 11 mod 3 plus 12 as our expression. Mod has a higher priority than plus, but that doesn't really come into play because we have parentheses, so we would be required to do what's in the parentheses first anyway. So 11 mod 3 is going to be 2. 2 plus 12 is going to be 14. So in this situation, we have declared the variable x and then assigned it the value 14. Something that is commonly said about Java is that it is a strongly typed language. What does that mean? Well, it means that the variable types draw strict lines in the sand about what can be stored in that variable. For instance, in the example, we have a integer variable called myNumber declared, and we are assigning it the value 7.5. Well, hold on. 7.5 is not an integer. 7.5 is a real. So for this reason, we're going to have a compiler fault, so it's going to throw a syntax error, and it's going to say you can't assign a real to an integer, error bad value. Under a certain set of circumstances, you can convert between one data type and another. As an example, we have a variable here declared called x, and x is an integer, and we assign the value 7 to the variable x. We declare a new variable called myVariable, and myVariable is a double, and we assign myVariable the value x. Now remember, x is an integer, so the value stored in x is an integer. So the right-hand expression in this assignment, for this assignment operator, is going to evaluate to an integer value. And then we're going to attempt to assign the integer value to myVariable. This will not generate a compiler error. The reason is because x's native type is an integer, which can be promoted to a double without losing any precision. Notice when we were talking about going from a double to an integer, we were losing precision, and therefore we couldn't do that. A double cannot be promoted to an integer. That would lose information. However, an integer can be promoted to a double without losing any information. So the compiler will automatically convert our integer value 7 to a double value 7.0, and store that value into my variable. When the compiler does this sort of automatic conversion from one data type to another, this promotion, it's referred to as coercion. So here's a handy reference for which types may be coerced into a more information-filled type. So a byte can be coerced into a short, short to int, int to long, long to float, float to double. Now, the important thing to understand here is any type to the left can be coerced into any type to the right. So you can promote from an integer to a double, you can promote from a byte to a double. As long as you're going from left to right, you can perform that promotion, and the compiler will automatically do the conversion necessary on the value stored in the variable. However, you can't go from right to left. So you can't go from a long to an int, because a long is capable of storing these very large numbers, which may not be stored into an integer. So in the previous slide, we discussed situations which some data types can be promoted or coerced into other data types without losing any precision. However, there are situations where you need to go the other direction. You know, in the reference from the previous slide, we need to go from, say, a long to an integer, but Java won't let us. So as an example, if we have some variable which is a double called distance, and we've assigned it the double value 9.0, and we have another variable which is an integer called points, and we attempt to assign the double value which is stored in distance to the variable points, the compiler is going to generate an error saying, no, you have an incorrect data type. It's in these situations that we need to make use of an operation called typecasting. So a typecast can be used to temporarily change the value of a variable from the declared type to the desired type. However, it's important to understand that typecasting does not change the the underlying type of the variable. It's a temporary change to the value which is stored in the variable. It doesn't actually change the type of the variable itself. So here we'll show an example of typecasting used to achieve the function we wanted to achieve. In the previous slide, we were trying to store the double value stored in distance into the integer variable points. So the way you go about that would be declaring the variable, assigning the value, the double literal value 9.0 to the variable distance, then declaring the integer value points, and then in the assignment statement we're going to use to assign the value to points, we're going to put in parentheses int in front of distance. So this is a typecast operation. So what's going to happen is when this expression is evaluated, the value which is stored in distance will be cast from a double into an integer, and then this resulting integer value will be stored, assigned to the variable points. So then when we print these to the screen, we do a print line statement and print distance, the value will be 9.0 because because the value stored in distance has not been changed. It is still a double. However, when we print points, the value will be 9 because the value which was stored in points was an integer cast of the value which was stored in 9. So the value of the variable distance after the cast remains 9.0. Previously we discussed that division, when involving a double and an integer, will evaluate to a double result. Another way you could go about this, if both of the operands were integers, you could typecast one of the operands into a double and then perform the operation. So in this situation, we have declared a double variable called result, and then we're assigning result the value which will result from the expression 19 divided by 5, with 19 being typecast as a double. So 19, as it's typed here, is an integer literal, which we are typecasting into a double. So the effect of this expression is 19, the integer value 19 becomes the double value 19.0, which we then divide by 5 to get the result 3.8, which is stored into result. Now, it's important to understand that typecasting does not round. Just as when we performed integer division, we didn't round, it truncated. Similarly, if you typecast a double into an int, the fractional portion will be truncated, not rounded. So, as an example of this, consider if we had the following situation where we declare another variable called int result2. So result2 is a variable which has the type integer, and then we assign result2 the value which will result from the expression typecast result from above as an integer. So result, if you remember, has the double value 3.8, and then we're typecasting 3.8 to an integer value. The 0.8 will be chopped off, it will be truncated, and the result will be 3. So typecasting from a higher precision to a lower precision data type does not round, it truncates. So a couple of things about typecasting. First of all, typecasting has a high precedence in the order of operations and only affects the value immediately to the right. The whatever is immediately to the right. So in the first example here, we are typecasting 1 from an integer to a double. And we have this resulting 1.0 plus 1 divided by 2. So the highest precedence was the typecast. Now the typecast is complete. The next highest precedence is the division. So 1 divided by 2 is going to result in the integer value 0. So we are left with the result of this expression being the double value 1.0. Similarly, we have 1 plus typecast double with the integer literal 1 being beside the typecast double divided by 2. So the highest priority, the highest precedence operation here is the typecast. So we have a result of 1 plus 1.0 divided by 2. 1.0 divided by 2, we have a double being divided by an integer, in which case we have a double result. So we get 0.5 as the result of that operation. Then we have the integer 1 plus the double 0.5. So again, we have an integer operand and a double operand, which will result in a double value. So we have the value 1.5 resulting. If you need to change the way in which typecasting will affect a particular set of operations, one way to do that is parentheses, because parentheses has higher priority than typecasting. So in the following example, we would do a plus b plus c first because of the priority assigned to it via the parentheses. Then we would typecast the result of that addition and divide this resulting double value by the integer 3 and result in a double value. This would be a way of calculating the double valued average of a plus b and c. Now, this is not the only way that you could do a conversion to double. We mentioned previously that if you mix operands, mix types of operands, then you achieve a type conversion. So, for instance, another way you could do the average of a plus b plus c and store it into a double would be to multiply the quantity a plus b plus c times 1.0. The reason here is because a plus b plus c will result in an integer value, which is then multiplied by a double value. The result of double multiplication with of an integer and a double is a double. So again, integer times double results in double. Then you have double divided by integer results in double. So it's another way you could do the same type change to achieve a double valued average. And then there's a further way to do it shown on the last line, where you simply, instead of dividing by the integer value 3, divide by the integer value 3.0. So you do integer addition, so this expression in parentheses will result in an integer value, and then you divide that integer value by the double value 3.0, so integer divided by double is going to result in a double. So there we've shown a couple of ways to go about the same desired functionality, which is achieving a double valued average given 3 integer valued variables A, B, and C. Now that we have an understanding of variables, let's return to our discussion of the customer receipt program and see how we can improve it and reduce the redundancy and increase readability by leveraging variables. To properly do this, we need to begin by stating what we intend the program to accomplish. So stating the problem or the goal. So in this case, our goal is to calculate the subtotal and then calculate the amount of necessary tax and tip, and then ultimately the total. So calculate the bill, we'll just say that to sort of encompass all of those, and then display the bill. So that's what we want this program to really do, is calculate and then display the bill. So the first thing we're going to want to do is not have it completely mixed up, where we are performing calculation and displaying at the same time. Let's calculate, then display, because that'll make more sense. We do all the calculations, store the results in variables, and then display the results of those calculations. Also, and I said this as part of that last statement, we're going to use variables instead of redundantly calculating our subtotal over and over. So, and also redundantly calculating our tax value and tip value. So we will remove redundancy, and we will increase the readability of the program. Okay, so here we have done precisely what we said. We are calculating the subtotal, then calculating the tax, tip, and then summing to find the total. Now notice here we are declaring our subtotal as an integer because each of the values involved in the subtotal are integer values, so that's an acceptable data type to use. So we declare a subtotal integer, and we assign it to the expression 38 plus 40 plus 30. So our subtotal then is 108. We declare a variable called tax of type double. Double because we're going to need to multiply by a decimal to get the required amount of tax. So we have a variable called tax, which is a type double, and we are going to assign it the expression subtotal times 0.08. So subtotal is an integer, but we're multiplying the integer by a double, and anytime you have an operator which has an integer and a double as operands, the result will be a double. So this results in a double value, which is stored in the double variable tax. Similarly, we're doing the same thing. We have declared a variable tip of type double, and we are assigning it the expression subtotal times 0.15. So that will evaluate, and the value of that the results from that evaluation will be assigned to tip. And finally, we are summing subtotal, tax, and tip to find the total, and it is stored in a variable called total of type double. After we've done all the calculation, we then will display the results using a single print line statement to display both the string describing what we are displaying, and then we're using a plus operator to concatenate the string with the double value subtotal. And we do the same thing for tax, tip, and then finally the total. A further improvement to this system would be to use class constants to hold values such as the tax rate, which are going to remain consistent and do not vary. So rather than using a literal value 0.08, we could have stored that in a class constant. Or an even further improvement would have been to describe or to write methods which would perform the various tasks for us, and this would involve decomposing and then writing reusable sections of code. Stay tuned for that in a later lecture. But let's touch on the idea of using class constants to store the tax value. So a class constant is a value which is visible to the entire class, not just the method in which it is declared. So if I declare a variable inside the main method, that variable is only usable inside the main method. However, if I declare a class constant, then this value, which is stored in the class constant, is accessible to any method which is inside that class. So one thing about class constants, though, as the name implies, they are constant. So once they are initialized, the value does not change. It is a constant. This could be useful because perhaps if we write this program, if in the future the tax rate changes, it would be much easier to change the value which is assigned to the class constant tax rate than it would be to search our program for every usage of 0.8 or 0.08 and replace it with a new tax rate. So it's much more maintainable and much more readable as well to use a class constant rather than using the double literal for the tax rate. The syntax used to declare a class constant is public static final, and then the type, and then the name of the class constant, followed by the value which you wish to assign to the class constant. And the style that we intend for you to use in the convention in Java is for all class constants to be fully uppercase with each word separated by underscores if you're using a multi-word class constant. So examples of this would be public static final, then type is integer, the name of the class constant would be days in week, then we use the assignment operator, and the value which is assigned is 7. So obviously the value which is assigned must be of the type integer. So we are assigning the integer value 7 to days in week, and that value will not change. So always, days in week, anytime we access that constant in this class, whichever class that this is used in, the value will always be 7. Similarly, to have a double class constant, which is what we would have in the case of our tax rate, we would say public static final double, and then interest rate in this particular instance. And notice it's all caps with the words separated by underscores, assignment operator, and then the value which you wish to assign, 3.5 in this situation. So now let's add class constants into our receipt calculation example program. So we have our class, which is called receipt, and at the beginning of the class, not in the main method, right? So before we enter a method, we will declare our class constants. So these class constants are valid and usable anywhere in the scope of this class. So we'll define it, or we will declare the class constant by saying public static final double. Then we're going to say the tax rate is equal to 0.08. So that's equivalent to an 8% tax rate. Notice we commented it as well. So we're using proper style and good documentation. Then we have public static final double. So public static final
are the keywords necessary to define a class constant. Then we have the type of the class constant. Then we have the name of the class constant, which is tip rate, and then we assign it the value 0.15, so 15% tip. And again, we're using a comment to tell what the purpose of this is. Then inside our main method, instead of multiplying by an ambiguous 0.08 and 0.15, we multiply by the class constant. Now the code is so much more readable. As you look at this, it should be eminently obvious what is happening. So we have an integer called subtotal, which is the summation of 38, 40, and 30. Then we have tax, which is a double that has the value subtotal times whatever the tax rate is. That makes sense. Similar with tip. Our tip is going to be the subtotal times whatever the tip rate is. And then the total is going to be the summation of subtotal, tax, and tip. This is readable, and without requiring much commenting, is easily understood and is transparent as to what the programmer is attempting to achieve. Much, much better than where this program started. And then, as we did last time, we will display the subtotal, tax, tip, and total. To summarize how we improved this program, we used variables to remove the redundancy of continually calculating the subtotal. We separated the components of the program into the calculation and to the display portions of the method so that it was easier to read. And then we chose proper identifier names for the variables such that they were informative. So subtotal is much more informative than variable 1. If that that would be an acceptable name should we have chosen it. However, variable 1 is not an informative name. So subtotal is an informative name which increases the readability of the program. Then the class constants we use are informatively named so that they increase the readability. The overall effect is a program which is no longer redundant and is now readable and therefore maintainable.